Hello class and welcome to the second video for this chapter. On this one, I am going to talk about net present value again, but we're going to compare two different alternatives. And when you're presented with two different things and you want to look at the net present value of each alternative to figure out which one is the best option. If you remember from our last video, net present value is the present value of all the inflows minus the present value of the outflows. Okay. If you're just looking at a project by itself, you want a net present value to be zero or higher, a positive number all the way down to zero. Because if you remember, we are using a discount rate. So in net present value, we are taking all cash flows at a predetermined rate that the company wants to make off their investment. That is called a discount rate. And we are taking all the future cash flows and discounting them back at that rate of return to find out if we have a positive value or not. Okay, so if you have a zero, it just means you are making exactly what the company wants to make. If you're making positive, you're making more than the rate of return required for the company. If your net present value comes up negative, you're making less rate of return, so it's not a project you will want to take on. You're going to use the same process whenever you have two different alternatives. Okay, this is exercise 12.7 out of your book. I don't have a handout for you, but it gives you all this information. Okay, so we have two different projects here. We're going to go find the net present value of each one of these projects, and then we're going to decide to do the project that provides the highest net present value, assuming that one of them is going to be positive. Okay, if they both come up negative, again, we'll just reject both projects. So we have project A and project B here. We have to introduce one new term. We have working capital. Sometimes when you go to do a project, as you see in project A, they spend $100,000 to buy equipment for whatever they're going to do. Another alternative for the company in project B is just to invest working capital. That means they're putting their money. Working capital, to me, when I hear capital, I think of money. It is what is needed to run operations, okay? It could be inventories, it could be supplies, stuff like that. It's kind of all classified in, but it's stuff that is needed to run operations, okay? So in project B, they don't need any new equipment, but they need to take $100,000 basically of cash and they need to invest it into this project, and it has to stay there. They're going to need $100,000 of working capital constantly in order to figure that like cash on hand, okay? They need that much cash to constantly buy supplies, pay their employees, stuff like that, okay? They're both going to get different amounts of annual cash flow. Salvage value, if you remember when we talked about PP&E back in the first accounting class, that's what you get when you're done with your equipment, you can turn around and sell it, so that'll be a cash inflow. There's no salvage value in B because they just invested working capital. But it tells you at the end of the problem that the working capital was released at the end of the project. So that counts as an inflow, okay? So we have 100,000 going out there. As you'll see when we start working through it, it'll be like $100,000 inflow coming back in, because all that cash that you had to have held there in order to run that project can now be released, come back to you. So it's just like getting it back, okay? Excuse me. The problem also tells us that the company has a discount rate of 14%. Okay, so that's all the information we need. From these two things, we can go through and we're going to figure out the net present value of project A, the net present value of project B, and you decide which one you want to do. So looking at project A, first, I like to break it down into what our inflows and our outflows were. So for project A, we only have one outflow. It is $100,000. And it happens right at the beginning of the project or today. So it is already at its present value. So we don't need to worry about it. I'm going to mark it up here. It's at its present value. Our inflows, well, we have annual cash inflows of 21,000. Okay. How long are we going to get them for? Well, we're going to get them for 6 years And we require, as I said, the discount rate of 14%, so we use 14%. This is an annuity. You think back to the last video if you watched it, an annuity is an inflow that is the same amount that happens on the same period, in this case a year. So they get $21,000, the same amount every year. Okay? Whenever you have the same amount over the same time period, that is called an annuity. That is important because when we find the present value of an annuity, which is what we're trying to find here, it equals the payment times our factor. Okay? We have the factor is what you're going to get from your charts. And I was just looking through the assignments, and I noticed that you're not going to be able to use my charts that I got for you when you go to do your homework, because it's going to give you wrong numbers for rounding errors. Okay, so use the charts that are linked in the homework and use those factors. But you would just follow, make sure. Let me grab my charts here real quick. Okay, remember we have these two charts here. We have the present value table and the present value of an annuity table. We have an annuity here. That's why it's important that you recognize it as an annuity, because you have to get the right chart. So our payment is $21,000. And our factor, if you go and you just follow the columns at 6 years, remember the periods are N and your percent is I when you're looking at the chart. Okay? So your N is 6, your I is 14. And that number I got from my chart with 4 digits times 0.38887. When you multiply them out, the present value of that is 81,622. Okay, so that would be the present value of all of the annual cash inflows. But we also have the salvage value. The salvage value is an inflow. I put PVLS, that is for present value of a lump sum. This is a one-time payment. It is called a lump sum problem. Okay, so when you look at your charts, instead of using the annuity tables, you will use just the simple present value table. All it says, and it equals the future value times the factor. And again, the factor is what you pull off the charts. Our future value, what we are going to receive in the future, is 8,000. Factor in this case is 0.4556. Equals 3,645. When you take 8,000 times 0.4556, that is your present value of the salvage. Okay. So now we've calculated them, we can find our NPV. The present values of the inflows minus the present value of the outflows. Well, our inflows, we had 81,622 plus 3,645 minus 100,000 for the original investment. We get a net present value of negative $14,733 for Project A. Okay. So if we were just looking at Project A by itself, it is definitely a no-go because it is a negative net present value. We are not hitting the 14% rate of return that the company requires, so we're going to tell them not to do it. So when we're looking at the alternatives between there, if B is at least 0 or a positive net present value, we are going to have a project to do. If that comes up negative also, we are not going to accept either project, okay? So I'm going to erase this, and maybe if you want, why don't you take a second, pause the video, try to find the net present value of part B, and then I'll erase the board and then I'll work through it with you. Okay, when we look at project B, we do not have the original purchase of the equipment, but at the beginning of the project, we still have an outflow of the investment of the working capital. And so we still have $100,000 getting invested, and it is today, so it is at its present value already. There is no need to discount it. Our inflows, you remember, our annual cash inflows are an annuity, so the present value of an annuity equals the payment times the factor. It is still 6 and 14, 6 for the N, 14 for the I, just as in the previous pump, so it's going to be the same factor. 16,000 times 3.88887. That equals 62,219. Okay. We also have a lump sum because the working capital is going to be released at the end of the project. So that is the future value times the factor. Remember, it is a lump sum, so you're not using your annuity table, use your normal present value table. But our future value in this case is 100,000 times point, same factor, 0.4556. And that equals 45,560. Okay. We find our net present value, the present value of all the inflows minus the outflows. So the inflows from the annual cash flows we calculated, 62,219, plus the present value of the release of the working capital, 45,560, minus the $100,000 initial investment, and we get a net present value of 7,790 on the positive side this time. That is a good net present value. That means we are making over 14% return on this investment. Our company is going to be happy. Definitely take option number B or letter B. Okay, so that is net present value explained again. And when you have two separate alternatives, there's two more things in this chapter. And I'm going to make a separate video for them. It is internal rate of return and simple rate of return. And then I'm going to work, so I'll explain them. And then I'm going to work through one more problem where we do the internal rate of return, but also included in that problem, we're going to have to calculate the net present value. So you're going to get to see this again one more time because this is one of the more difficult concepts, is time value of money. Even in my intermediate classes, we talk about this, and they still struggle with that up at the junior, senior level. So hopefully this is helpful. And as always, reach out to me if you have any questions, and I'll have the next video for you soon.